things, and they need to have one of those items to then use their computer. And so it's a proximity thing, that if they don't have the RFID tag, it won't even let them use their computer. In this space, with the has tokens, what are our attack vectors? Stealing it. If you stole my keys, you get this, plug it in, press the little button, you're good to go, except that there is a password to put in conjunction. So I have this and something I know. But flogging this is probably not a bad step, especially if you can find out my password first, then steal this, then you're good to go. Forgery. The FPOS thing is a classic case for this. Stolen credit card numbers that get printed onto cards is what was very common, and now basically only happens in America because they're a bit behind everyone else. They're just going to chip and pin now, and the rest of us have all had chip and pin for years. So there's lots of examples of forgery around tokens. Biometrics. Now, these are really fun and interesting, and it's a space where you see a fair amount of excitement in general population about them. You know, for example, Apple released their new phone. Everyone goes, "Oh, it does your face." You know, some other Android phones have done similar things for a while. Whenever we go through with our e-passport in Australia, it does a facial thing for the last decade. You know, facial recognition-y stuff isn't actually a new concept. It's been around for quite a while. We'll have fingerprint scanners on our phones, incredibly common. Some people's laptops have a fingerprint scanner on it. Iris scanning as well. So some of these get combined with other factors, like our passport. So I'm going to Singapore in a week or two, and I'm actually in the process of getting a new passport because mine's about to expire. Hopefully it arrives before I've got to go. But that, I have to present my passport, and they scan the little number, and then it does facial recognition. So it's two factors, having the passport and then the facial recognition. It's the two factors there. What kind of threats do we have in this space? Well, my fingerprint is not private. It unlocks my phone, but it's not private. I mean, I've been standing here now at the front for 43 minutes-ish. I've touched this, I've touched that, I've touched this screen, my drink bottle. My fingerprints are everywhere here. It's not actually private. It's not hard to steal a fingerprint off of a surface and then try to use it. We've probably seen that in countless movies and things like that. Or certainly in contexts where a policeman in a movie might get someone's fingerprints and put them. Anyone seen the new Red Sparrow movie? In that, Jennifer Lawrence steals a glass that had scotch in it, got a bunch of fingerprints on it on another spy. She then puts that glass at effectively a crime scene. I won't spoil too much. But then that person, they're like, "Oh, they were there." She frames them because their fingerprints are at the crime scene. So on the biometric thing, it's measures of what we are. So a factor to consider here is if they get stolen, we can't get new stuff. It's very hard to get a new face. I mean, you kind of can, a bit of plastic surgery. It's very expensive, and I don't think you want to have to get, a face job every time someone steals your biometrics. The original concept of measuring people based off of this in sort of a police context was in France in the sort of 1870s. That's what Bertin Menage, I don't speak French, I don't know how to pronounce that correctly. And what they did there for 2 years before they realised it really wasn't working and stopped doing it was all the criminals, when they put them in jail, they'd measure their height, their weight, their eye colour, their hair colour, the width of their hand, and like 3 other things. So they had about 10 measures on people. And then they were like getting descriptions of crimes occurring. They're going, how tall was he, what hair colour was, oh, he's this guy then, because we've got someone that matches those measurements. But they weren't unique. They were way too generalised, and it meant that people kept getting done for crimes that they clearly couldn't have done. So our ratio of how well we can identify one person in a population, that ratio, is it 1 to 100, is it 1 to 10,000, is it 1 to 1 million? That ratio is dramatically important with biometrics. It's really interesting at the moment in court cases around DNA, because we all know our DNA is basically unique, and that's correct. But the accuracy of labs is not 1 to 6 billion. The accuracy of labs is like 1 to 600,000. So there's this very strange thing when there's a few court cases have been turned over when they've actually realised that, oh wait, no, the lab accuracy is why we thought his DNA matched when it didn't. There's been a few cases around that space. So our biometrics are what we are. There's a whole range of ones. There's face, there's fingerprint, hand geometry, iris scan, retina scan, our DNA. But there's a whole bag of issues there. As good as it is to go, oh, it's my fingerprint is not actually private. I'm not a fan of the idea of trying to sign into my laptop with DNA. That sounds like a bit of a dud idea to me. I don't particularly want to give my DNA to whatever company it is that's doing that. But there's a lot of range here. But with all of these, they're basically things we can't change. So we're trying to measure our physical characteristics, which are us. Some of them are a little bit more behavioural, and they're quite interesting. Speech recognition. I don't know how many of you have got an Amazon or a Google Home and things, but Google Home specifically, certainly, can detect your voice and know it's you. So you have it tied into some things that can cost money, and you can order stuff. But if a friend comes over, you don't want them ordering things randomly. So it actually does know who you are. It learns your voice. And in the case of the Google Home, for example, our one at my house detects my voice and knows me and interacts with my accounts. And with my wife's voice, it then interacts with hers. So if she says, add this to my calendar, it goes to her calendar, not mine. It does voice recognition there. So some of those things are becoming incredibly common now. But my voice is my voice. It's changed once in my life. I don't want it to change again. So what the user is. Coming around to a few problems. I've started to mention some of these. Classical problems still exist in this space. So as we think of the problems that can occur with passwords, if we then think about them in the context of biometrics, they still can apply. Key decay, right? The more we use the same piece of authentication, the less well it's secured, the less secure it actually is. If we use our fingerprint on lots and lots and lots and lots of different systems, we've actually spread the model of our fingerprint as represented with dots and circles and lines. That's how it sort of tends to get represented by the system. We end up spreading that model everywhere. That model isn't actually 100% unique. It's actually trying to take a very complicated fingerprint and measure it and store it in a very small amount of information. And so if we use it everywhere, it might then get stolen. A person might find a fingerprint that's very similar or modify theirs into what it matches, and then we've got an attack vector where they can beat our biometric. Faked, as I've already mentioned, it's often not secret information. Some of it might be kind of hard to get. DNA is a bit harder to get than our fingerprints. But things like facial recognition. The picture that goes through with my passport is just a straight-on picture of me. My Facebook and other social things are covered in pictures with straight-on pictures. So from a facial recognition perspective, it wouldn't be hard to actually fake those sorts of things. And we've seen examples of that with Apple's facial recognition stuff. And putting a bit of plasticine on your face and away you go. So if you get stolen versions, you can then see, well, what happens if it's actually going through to a server and it's about producing a model that matches and then transmitting that model. If someone gets that representation, that stolen digital copy that is the model representation, it is a bit easier to use. So this all boils down to is, has and knows. So our three categories here. For stronger security, we want to use multiple of these. The strongest security we can do is being in the middle with all three factors. So lots of things that we do these days, like our bank, want us to have two factors. So we might put in a password and then we suddenly get a little alert, an SMS on our phone, a code to put in. It's proving second factor in that we have our phone. Second factor, they're more convinced it's us trying to log in, therefore they'll let us in. So two factors are stronger than one, and three is stronger than two. But there's always going to be that cost there. Another one that comes up from time to time, which is kind of definitely in that token sort of category, which can tie in a little bit here, is encryption keys. That's one way we actually prove who we are. That whole public-private key pair scenario we saw introduced in 501, and the way we might sign a digital signature and those sorts of things. Encryption keys fall under that category, and we'll talk about those more later. They are basically a token, a thing we have, but there's a nice little category there that we're using quite different in some contexts. So we're not going to talk about it too much today, but we will see later when we look at protocols that encryption keys are very commonly how we prove who we actually are. So authentication, already said all of that. What we can do, though, is break this down into two halves, passive and active. And that's what we're going to look at in the second half, as we start off at least. So we'll have a 10-minute break there, and we'll reconvene at 8 minutes to 12. But we'll come back in looking at passive and active authentication. Okay, let's get going. Before I launch into the second half, a quick little thing, an apology again to the people in the 9 o'clock tutorial this morning. This year the Networks Lab has been moved how it's being administered, how it's being run to a different platform. And so I spent most of the summer, from November through, working with the people who were supposed to take it over. It was a decision made above me, not by me. And so that meant that as a result of it not working properly, the lab actually had issues last Wednesday. And basically from last Wednesday through up until including this morning, it wasn't working. So the 9 o'clock class this morning actually had to get cancelled, along with a whole day of classes on Friday for another unit got cancelled. So apologies again to the people in the class this morning. We'll reschedule that and I'll email you, but it'll be 1 o'clock on Thursday. The 1 o'clock Today tute, I'm hoping that when we leave the lecture and go to the lab, it'll be working. Otherwise it'll be rescheduled. But I just checked my email. I haven't heard anything yet. But they've got an hour. Maybe they'll get it going. I'm smiling, but I'm actually very angry on the inside. I was here till 1 a.m. on Saturday night, and I was here late last night, and I've actually been here every single day working on the lab with them since the 8th of February, except for one day. The 25th of February is the only day since the 8th of February I've not been on campus working on the lab. So, yes, frustrated is not strong enough a word. Okay, so continuing on with authentication. What we've just seen is those three kinds. Knows, has, and is. We're now going to look across at the two modes of authentication we see. And hopefully these will become recognisable to you. But now we'll actually talk about them in a more structured way than you might have thought. So the first one is passive access control. Now, this is when the computer responds to a claimed identity. That's what the passive is. The passive, the computer is sitting there, and then you walk along and say, I'm Bob, I want to sign in. The computer hasn't extracted the identity from you. You've provided it. You've claimed an identity, and then a verification follows. So this is the most common form that we see, in that we go in, we type in our username. That's passive. We've typed in a username, and then we're verified. That's passive. If we arrived at the computer and it then typed in the username for us, it knew it was us, then we're talking about active, but we'll see examples of that in a moment. So under passive, the process isn't initiated by the computer. It's initiated by the user, and they provide their credentials, they claim an identity, and then they actually validate that. It's a one-to-one relationship. We're thinking about databases. We're claiming an identity and matching it to the credential. It's a one-to-one relationship. It's very fast, very efficient. Question and answers are another example of this. They're quite interesting as a way of doing stuff that we know that's not a password. So we call up our bank and we say who we are, so it's passive. And separate to password options, we might have things like, what was the town you're born in? What's your mother's maiden name? Those kinds of very annoying, boring questions are what we're talking about there. Particular questions. But they're an example of that. Challenge response is another one of these that's quite common. They know who we are, and they might then actually give us some sort of way of producing an answer for them, whether it's a number. Now, they've got an example here, a little algorithm that might be that they tell us a number, we then respond back with an answer it expects. The little example that's there you can play with if you want is giving numerical values to each letter of the alphabet and then sort of adding them together and multiplying it, sort of thing, playing around with it. So these kinds of things, challenge response, question answer, passwords, in response to us claiming identities, passive. They're verifying us, they're authenticating us, but only when they know who we are initially. That we've claimed an identity. We've said, I am this person, and they follow on with this range of different things we've got. Now, in this context, again, the ATM, we can actually claim an identity by putting in our card. That's passive as well. The ATM isn't figuring out who we are when we walk up to it. It figures out once we give it our bank card, and it goes, this is that guy. I know who this is now because he's just claimed an identity. It's a passive thing. A lot of systems that we use, in fact, the vast bulk of the systems we use, fall under this passive category. We claim an identity. It makes it fast, it makes it efficient, it makes it a one-to-one, keeps the errors down. These kinds of things, in terms of the stuff we have, they're quite useful, especially if you compare a key card to just a password. You've got to physically have it. All my bank cards are in my wallet, right? It's something I automatically protect. So if you stole my wallet, I know fairly quickly, because I'm constantly checking, do I have my wallet, do I have my phone, do I have my keys? You know, you do the three check. Both back pockets, both front pockets. Have I got my stuff? You know? With a password, if you stole my password because you watched it over my shoulder, I've got no idea that you've got it. I can't check, has someone known my password? You know, that's not a thing. So those kinds of things that we've got are quite useful. It's all about possession. It's all about possession, which is quite useful. That's a great advantage of that. But it is just possession. So if you do successfully steal it and I don't notice, all it's proving is possession of that thing. For our second factor, this is probably one of the more common second factor scenarios. We present a thing, then we put in a PIN number. It's probably the second factor thing that most people have as their only thing they've got as a second factor. Us nerdy types tend to choose second factor and other things quicker, but if I imagine my grandparents who can't use a computer and think of what things do they have that are second factor, their bank card is their only thing that they've got that is actually second factor, and they've had that for decades. It's a classical solution that these days we're using a lot more in a lot of systems. So again, our biometrics can be used in a passive context as well, and it's